the shadows of Mount Everest, a train awaits. But be warned, those attempting to reach the summit must face him. Expedition Everest, a chilling new ride, only at Disney's Animal Kingdom Park.
And now, here's an Everest Insight with Survivor Man Les Stroud.
When Edmund Hillary and Tenzing Norgay summited Everest in 1953, they might have had an ice axe just like this one, glacier goggles, crampons just like these. Modern equipment hasn't changed much, just gotten lighter and stronger. Pretty important factor on a grueling climb, 29,000 feet above sea level. An aluminum ice axe like this weighs only a quarter of this baby. And every ounce counts. At the extreme altitudes of Everest, a heavy pack might start off at 50 pounds. But on the final push for the summit, it's down to 15 pounds, carrying probably only an oxygen canister and an energy bar. All right, and a camera too. Aside from a sleeping bag and a tent, some of the equipment that's going to help you summit any peak, including Everest. Some rope, climbing harness, stove, fuel, pot for cooking. And as well, you've got your more technical climbing gear. Carabiners with pulleys and ice screws. Of course, just as vital as your equipment is your clothing. Every climber dresses in layers. A wicking layer close to the skin so the moisture wicks away from your body. And then the layers get thicker as you move on out, each one trapping in a bit of air, another level of insulation. If you wore just one big thick layer, you're gonna sweat too much. You take it off, and you freeze. And there's the key point. You start sweating, and the wind can just wick away all of that heat right away from your body, chilling you down quickly. And hypothermia is not far beyond that. So there's Everest Gear 101. Pack light, pack warm, and dress in layers.
Stay tuned for more from Les Stroud as Building a Thrill Ride Expedition Everest continues.
For months, a team of engineers and artists has been recreating a Himalayan mountain range in Orlando, Florida. It's all part of a huge new attraction that includes a roller coaster screaming through a forest haunted by a Yeti.
We should be able to come back in, kind of, again, crisp up these edges a little bit.
Artisans have to access every square inch of the mountain to put on the rockwork face. To get the look and perspective right, they have to see the mountain from a distance. But traditional scaffolding would be too cumbersome and block their view. Trying to do both has the design team caught between a rock and a hard place.
It's a mass of scaffolding, and it's all on the outside, and we can't see through it to see the mountain, to see what we're doing. We can't use traditional scaffolding.
They come up with a solution.
Instead of doing conventional scaffolding out here, what I think I might be able to do is from the structure come out with members that just come out and provide a working surface. It's going to look like toothpicks coming out of the mountain.
They'll need more than 2,000 of these giant steel toothpicks to support the scaffolding.
This right here is a typical tab arm. It's a channel that goes back and is supported by our structural steel. And we had it extend out 5 feet so that we could put planking on it and create self-supporting scaffolding.
Once the construction workers are done with a section of the mountain, what do they do with the tab arms?
We can then cut off the tabs one by one.
Chris, go ahead on over there and cut that one off.
Cutting them all off took almost 3 months.
And an engineer looking at this mountain 3 years from now is going to go, how was this possible? Because the clues will be gone.
The tabs also solve another problem: how to attach a rock-like surface to the steel framework of the mountain.
What we decided to do was a new method that we ended up calling the chip method.
They made more than 3,000 rectangular rebar grids called chips, each as unique as a puzzle piece, with its own specific place on the 3D puzzle of the mountain's rock face.
And the chip method is taking that chip and hanging it on tab arms.
The same tab arms used for the scaffolding. To make the chips, designers used a computerized model they made earlier in the design process. Now they divide it into modules or chips, approximately 6 foot square.
Those modules are then bent into the rebar profiles that you see here. Each bar is a 3/8 inch diameter bar, and they're unique to this position on the mountain.
It takes almost 32,000 bags of cement to make the outer crust that covers the rebar chips.
We need to make sure we get at least a couple big drifts of snow within this little rock formation that we've got.
A mountain range now rises into the Florida sunlight, but it just doesn't look like the Grand Himalayas yet. The Imagineers need to fool Mother Nature and Expedition Everest guests into thinking this is real. Maybe the designers were unwrapping their sandwiches for lunch when they came up with the answer: aluminum foil.
And it's in effect a flexible form. We're able to do the basic shapes by troweling the cement, and then while the cement is still wet, we can press this and emboss this foil into the surface and actually sculpt it. Then later that foil will be removed, and our sculptors will go back over the entire process with a series of brushes and tool marks to finish it up. What we're looking for are very crisp, sharp rocks. This is the Forbidden Mountain Range, so everything is sharp, it's spooky, very scary type of geology.
In the story, the Forbidden Mountains are very high and very far away.
One of the things that we were trying to do is create the perspective of the Himalayan range, and some of the low peaks are 20,000 feet. Mount Everest itself is 29,000 feet.
How do you get that much distance on just a few acres of land? Using a trick of the trade called forced perspective.
That's a process where we try to make an object look bigger than it actually is, where we have a foreground, negative space, a midground, negative space, and then a background.
Forced perspective is common on a smaller scale in set design and painting. But this may be the world's largest set, so this is tricky. The mountains have to look realistic from both near and far. Guests may even snap a closer look with telephoto lenses.
When the guests are very close to the rockwork, the rock has to appear to be one-to-one, and as the guests are further from it, then it has to be increasingly further and further away.
In order to accomplish the illusion of the mountain looking 30,000 feet high, we have to reduce the scale. When I'm instructing or directing the crew, I often use examples like, well, picture a Greyhound bus if it was that big.
If one way to create the illusion of distance is with scale, the other is with paint, and lots of it. 2,000 gallons, dozens of colors, 20 painters, and an artist's sleight of hand.
Because if we paint every portion of the mountain highly realistically, it's not going to read properly. So we've really got to make adjustments in color and value. Even the snow is not all the same color white. We have 4 different grays that we paint for snow.
Even with the bugs worked out of the mountain, there's still a lot to do before opening day. The story calls for building a Tibetan village that looks like it's centuries old, and a roller coaster that looks like a steam train. Climbing the real Everest might be easier than this.